So in this session, we will solve some of the questions that came up in May SAT test, the last digital one. Unfortunately, we do not have enough time to go through every question, and I don't want to burden you with a lot of stress just the day before the test. However, we will go through some of the hardest questions, this file itself. So hopefully the session will be helpful for all of you. And yeah, let's go. So we are given two cylinders, cylinder A and cylinder B, as well as the radius of cylinder A, which is 4. And you are given also the surface area, but not in numbers, in unknown values, which is d by for cylinder A, and the surface area of cylinder B as well. And he's asking you to find the difference between the surface area of cylinder B and the surface area of cylinder A. Okay, so the first step here is finding the surface area of cylinder A, okay? We already know that the volume of a cylinder is equal to by r squared multiply the height. R is the radius. So we know the volume, which is 300 pi. So we can say that 300 pi is equal to pi multiply r, which is the radius, which is equal to 4. And 4 to the power of 2 is equal to 16. So we write down 16, multiply h. We can cross out by, and there will be left with 300 and 16h. And then we will divide 16 in both sides. So we can get the value of h, which is equal to, so the value of h is equal to 18.75, okay? So now that we have the value of r, which is equal to 4, and the value of h, we can plug in these values into the area given in order to find the surface area of cylinder A. Is it clear so far? Yeah.
Yes. I have a question. What is 75 here?
Sorry, 75. That's the value of h. Value of h is equal to 18.75. Okay.
But
so
how did we find? Like, if we divide it, we have 18 only.
now we will divide 300 by 16 to find the value
Okay.
of h. So it will be 18.75. So now we'll plug in these values into the surface area equations that we have. So we will have a 2 pi multiply r, which is equal to 4, multiply h, which is 18.75. And that's added to 2 pi multiply r to the power of 2 is equal to 16. So that will be equal to 2 pi is that's 32 pi, and that's equal to 8 by multiply 18.75. Just let me plug in that into the calculator. So it will equal to 182 pi. Okay, and there's a surface area of the first cylinder that's equal to dA. Sorry, d multiply pi. So the value of d is equal to 182. Now, let me clear up some space. Yeah, great. So you are also given an important piece of information here that both cylinders are similar. So they have a ratio between each others. So the volume of cylinder A in meters cubed have a ratio to the volume of cylinder B in meters cubed. So we can say that 300 pi to 8,100 pi. Okay, that's the two volumes of the cylinders. Since the cylinders are both similar, they have a ratio between them, and we will get that ratio. So we will divide by the least common multiple, which is 300 pi. Okay, if we divide by 300 pi in both sides, 1 is the left hand, and on the right hand, 81 divided by 3 is equal to 27. So we will have 1 to 27, and that's the ratio between the volumes of the two cylinders. Is it clear? Okay. So what will be the next step? The next step will be finding the ratio in meters. So just take care. The ratio here is in meters cubed, which is the volume. However, we cannot use that ratio to get the surface area of the other cylinder, which is B. Okay, so we should convert meters cubed to meters, and then convert meters back to meters squared. Okay, let me clear up some space first. We don't need that. We don't need that. Yeah, just let's say dw is equal to 182 pi. Okay, so in meters, we can get the ratio in meters by getting the cubic root of both sides. Okay, so getting the cubic root of 1 is equal to 1, and getting the cubic root of 27, the cubic root of 27, if you plug that into your calculator, you will have 3. That is in meters. We need to find the ratio in meters squared to find the surface area of cylinder B, since both cylinders are similar. The new conversion rate, or the new ratio in meters squared, we will power each side by 2. So we will have 1 to the power of 2 is the same as 1, and 3 to the power of 2 is equal to 9. Okay, so now we have the ratio between the surface areas of the two cylinders. So in other words, let me clear up the bubbles since we do not need it anymore. Surface area of cylinder A, which is 182, right? So we'll plug in that here, 182 pi. And let's say the surface area of cylinder B is equal to x. So what we are going to do is cross multiply, and then we will solve for x. So we'll have x in one side, x multiply 1 is equal to x, and 182 by multiply 9 is equal to 182 by multiply 9 is equal to 1638 pi. And that's the surface area of cylinder B, which is equal to t multiply pi. So we can say that t pi is equal to 1638 pi. So the last step here is finding the difference between t and d. And we can do that by subtracting t minus d. So the value of t is equal to 1638. Okay, we can cross out pi on both sides. The same with these, the value is equal to 182. So the final answer will be equal to 1,456. And that will be the answer for this question. Let's solve question number 3 and then move on to another question. So here you are given a function f of x. Let me write that. So f of x is equal to absolute value for x divided by s minus 10. And he's asking what is the sum of f of 15s. So x is equal to 15s. And the other one is x equal to 3s. So since the value for s is equal to negative, we can do a quick tip here. Because we have an absolute value, we can put a negative sign beside s in the denominator, and then plug in the values, okay, into the function immediately without doing any changes. So we will have 15s divided by negative s minus 10, and that's equal to s divided by s will just cancel out, and we'll be left with negative 15 minus 10. Negative 15 minus 10 is equal to negative 25. So the first value we have is negative 25. Now we'll plug in 3s into the function again, okay? So we will have 3s divided by negative s minus 10. And s will cancel out with s again, and we will be left with negative 3 minus 10, which is equal to negative 13, okay? So what is he asking for? He is asking for the sum of these two values, negative 13 and negative 25. Let me clear up some space here. So negative 13 plus negative 25 is equal to 8 and 3. So the answer is negative 38. 5 looks a bit scary, so we're going to solve it. So So here you are given a circle, and inside that circle, there's a square, which is AB and ABCD, okay? Sorry, the circle is inside the square. And you're given a segment AC, which is this one here, the straight line. And it says that this is the diagonal of the square and its length is equal to 10 centimeters. And he's asking about the radius of the circle. So it looks a bit difficult, but here's the deal. You should know that if we draw a straight line, let me draw a straight line here like that. This straight line represents the diameter of the circle, right? And this straight line corresponds to this one here, which is the side of the triangle, or the other side of the square. Okay, so we can say that segment AD is equal to the diameter of this circle, right? So since we knew this small piece of information, we can work on to get the value of AD. So we know that a square have a 90 degrees angle, right? So this angle here is a 90 degrees. And the diagonal of the square crosses or splits the 90 degrees angle into two equal parts. So if we redraw, let me redraw this side of the square here. Yeah. If we redraw this side of the square here, we know that this angle is equal to 45. And we know that this angle is equal to 90 because this angle is actually related to the triangle. It's a right angle. So it's equal to 90. And since the square is 180 degrees in total, so we have a 45 minus 90. We know that the last angle is equal to 45. So if you had a look at this triangle here, we have a special triangle, which is 90, 45, 45 triangle. And the size of this triangle is equal to x root 2, and this side is equal to x, and the other side is equal to x as well, since the opposite angles of both sides are equal, which are 45 for both. So we know that the hypotenuse, or x multiply root 2, is equal to 10, right? So we can say that 10 is equal to x root 2. So solving for x, we get a value of x. We get a value of x that's equal to 10 divided by root 2. If you plug it into your calculator, I guess this will equal to, this will equal to 5 multiply root 2. Okay, so we know that this side is equal to 5 root 2, and that side is equal to 5 root 2 as well. Okay, so now we know the diameter. We know the diameter of the triangle. The diameter of the triangle is equal to 5 root 2, because as we said before, AD is similar to the diameter of the triangle. Since AD is equal to 5 root 2, the diameter of the triangle is equal to 5 root 2 as well. So the value of radius in the circle is equal to the diameter divided by 2. So we would divide 5 root 2 by 2. So the answer for this question will be choice D. You are given two right triangles and they are similar. And A corresponds to D and B corresponds to E. So this one here corresponds to that. And C, of course, will correspond to F. And you are given the value of 10 angle A, which is equal to 15 divided by 25. So 10A equal to 15 divided by 25. And the tangent of an angle, the tangent of any angle, is equal to the opposite side divided by the adjacent side. What is the opposite side to A? It is this one here. So we can say that this side here, which is PC, is equal to 15, right? And the adjacent side is that one, which is equal to 25. Now, let me clear up some space. Now he wants us to find the value of tan of f. Now, where's angle f? It's there. We know that the tangent of an angle is equal to the opposite divided by what? By the adjacent side. So what is the opposite of angle f? It is this one here, x. Let's say it's x, and let's say it's y, and the adjacent is here, which is x. So as you can see, tan f is equal to y divided by x. And since both triangles are similar, we can say that y is similar to 25 and x similar to 15, since they both have the same ratio. They do not have to have the same exact value, but they have the same ratio. Okay, so the answer for this question will be 25 over 15, since the tangent of angle f is equal to the opposite side, which is this one, which is corresponding to 25 over the adjacent, which is x, and it corresponds to 15. So the answer is choice A. So what is the value of x? It's asking you for the value of x, and you are given two intersected triangles, okay? Now, you can split these triangles like that, you know? So this angle here is equal to 110, that is equal to 25. So 180 minus 110 is equal to 70 minus 25 is equal to 45, okay? And then let me clear that. We know that this side is equal to 45. So this triangle here, we can work separately on this triangle. So 45 plus 110, and then we can subtract that from 180, which is the total values, the total measurement of all angles of the other triangle to get the value of x, which is this one here. So 45 plus 180 is equal to 150. They will subtract x will equal to 30. Want to try 22?
Yeah, let's solve this one.
Yeah, I think it's an interesting one. So you're given a quadratic function, which is this one here, in the vertex form, okay? And this quadratic function in the vertex form can know the value of x of the vertex point. We know that the vertex form, if we draw a function like that, the value of x is equal to negative 3.25. Okay. And it's also said that this function can be rewritten in this form, which is the factors form. Okay. And he gave us a condition: if a is equal to 1, what is the value of d? Okay. So you should know one piece of information that's crucial to solve this question. At the vertex point, this one here, there is an axis of symmetry. Let's assume that this is a point of vertex. We don't know yet. Okay. And so, and this will be the shape of our parabola. Okay. We know that the value of x here is equal to negative 3.25. And as a vertex point, there is an axis of symmetry. The definition of an axis of symmetry is that it splits the function into two equal parts. So since we have the factors form here, we can get the solutions of this function. We can equalize it to 0. So we can say that x plus 8.75, x minus c. So we'll solve once for this and once for that. So we will have the first solution is negative 8.75, and the other solution is c, positive c. But anyway, we don't know the value of c yet. Just let's see how it will be. So we know that this one here is equal to negative 8.75, right? And since the vertex point splits the parabola into two equal parts, the distance between this point here and the vertex point on the y-axis, okay, is equal to the same distance between the vertex and the other solution. Okay, so what we are going to do is that we should find the distance. Okay, so the distance between these two solutions, these two values, which is negative 3 and negative 8.75, that's negative 5. Okay, so the difference is equal to 5. So we moved 5 units into the right direction, sorry, into the left direction to reach the first solution. And we'll do the same thing. We'll move 5 points to the other direction to find the value of C, or the other solution for this equation, or for this quadratic function. So we will add negative 3.25 plus 5. That's equal to 2.25. Okay, so actually it is positive. Let me redraw the graph. So that was our graph here. We have the vertex at this point, the first solution here, and the second solution will be here. It will be something like that. Okay, and it's given that the value of A is equal to 1. Okay, so since we know the value of C, we know that this one is equal to negative 8.25, and this one is equal to 2.25. We can plug in the value of C into the function here. It says that the value of C is equal to 2.25, right? And then we plug in the values of C into the function. So we can say that x plus 8, 0, then what's multiply x minus C, which is 2.25, is equal to this one here, which is A. A is equal to 1 anyway, so we won't write it, which is equal to x plus 3.25 to the power of 2 minus D. So to make it easier, we will expand this function. So we will have an x to the power of 2. Okay, it will be an x plus 3.25 multiply an x plus 3.25. So x multiply x is x to the power of 2, and then x multiplies 3.25, and x multiplies 3.25 another time will equal to 6.5x. Okay, and then we will have a 3.25 to the power of 2. Just let it be to the power of 2. No need to expand it. And then we will expand the left side as well. We will have an x power 2, and then we will have a negative 2.25x and 8.75 multiply x. So we'll have a positive 8.75x, and then we will have 8.75 multiply negative 2.25. Okay, let me clear some space. This 2 is not being erased. So if we added these values, we'll have an x power 2 negative 2.25 plus 8.75 is equal to, sorry, it's equal to positive 6.5x, and that plus 8.75 multiply negative 2.25. So x bar 2 corresponds to x bar 2. 6.5x corresponds to 6.5x. And we will be left with this value here, which is 3.25 to the power of 2, and that will equal to 8.75 multiply negative 2.25. Okay. Yeah, sorry, it's 3.25 minus D. I forget the D. We're actually solving for D. About 2 minus D is equal to 8.75x. Sorry, multiply negative 2.25. Let me clear this space here. Okay, so what we're going to do is that we will move 3.25 to the power of 2 to the other side. So we'll have a negative D is equal to 8.75 multiply negative 2.25 minus 3.25 to the power of 2. Plugging that into your calculator to find the value of negative D. So just let me plug in the values. So negative D will equal to negative 30.25. Okay, so the value of D is equal to 30.25. So the answer is 30.25. The quadratic function f of x has two solutions, j and k, where j is less than k. And the quadratic function g of x has two solutions, which are L and M. This one here, where L is less than M. And we have a third quadratic function, which is h of x, which is given as x plus 9x to the power of 2 plus c. And it said if k plus j, L plus m are the solutions for this function here. And h of x can be rewritten as this one here. What is the value of c? So we want the y-intercept of the function h of x. But first, in order to do that, we need to get the solutions of the function to plug in it in these values here, a and p, and then extend it and equalize it to that one. Okay, but in order to get the solutions of the function h of x, we need to find the solution of f of x and g of x. Okay, so you have two ways to find the solutions, either by factorization or Desmos. Since Desmos is a bit easier, I will use Desmos. Just let me open my browser. Okay, so the first function is x power 2. The first function is x power 2 plus 3x plus 4, I guess, right? Yeah, no, minus 4. It's minus 4. And the second function is x power 2 plus 6 minus 16 plus 6x minus 16. So what we are looking for as a solution for the function, or in other words, the points at which the functions intersect this x-axis here. Okay. So let's start with the first one in red, which we have negative 4. That's the first solution, and the second solution that's equal to 1. Okay. So the first function, we have a solution which is equal to negative 4 and solutions that's equal to 1. What about the second one, the one in blue? In the one in blue, we have a solution which is equal to negative 8 here and 2 right here. So we have a negative 8 and 2. Okay, that's the solutions of the function. It's not the point, the solutions. Now, let's get back to our question. We know that the solutions are for f of x, the solutions for f of x are the following ones. They were, I forget them, I think they were negative 4 and 1, and g of x were negative 8 and 2, right? Yeah?
Yes.
Yeah, great. So what we are going to do next is finding the solutions of h of x. We are given that the sum of these two solutions here, the sum of this solution, or the sum of the solutions of f of x, give us one solution of h of x, which is k plus j. Okay, so negative 4 plus 1, the first solution for h of x, negative 4 plus 1 is equal to negative 3. That's the first one. And the second one, g of x, negative 8 and 2. If we added them, we'll have a negative 6. Okay, but these ones are the solution. And we are given the function as factors. Let me clear up this small space up. Yeah. So in the factor, we can say that a is equal to 3 and b is equal to 6, for example. So x plus 3 multiply x plus b, which is equal to 6, is equal to the function h of x. Okay. And we also know that h of x is equal to this equation here. So we can equalize them to each other and then expand the left side. Okay. So we will have an x plus 3 multiply x plus 6 is equal to x plus 9x power 2 plus c. Expanding, we have an x multiply x is equal to x power 2, and x multiply 6 is equal to 6x. And 3 multiply x is equal to 3x, and 3 multiply 6 is equal to 18. So 6x plus 3x is equal to 9x, and that's added to 18 and x power 2. So as you can see, the values of x to the power of 2 correspond to the value of x to the power of 2. 9 corresponds to 9, and the y-intercept, which is c, is equal to 18. So the answer for this question is 18.